This is our fourth experiment. Today we are going to deal with Bayesian algorithm. We are using the given data set to build Bayesian network-based classification and analyze the effect of feature selection on this method. Before going to the experiment, I will give a brief introduction on this Bayesian classification. The Bayesian classification is based on Bayesian's theorem. Bayesian classifier can predict class membership probabilities such as the probability that a given tuple belongs to a particular class. A naive-Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of other features. So to begin with this experiment, I am taking the iris dataset and I am using the cross-validation operator. The cross-validation operator is used to estimate the statistical performance of the learning operator. It is namely used to estimate how accurately a model will perform in practice. The cross-validation is a nested operator. It has two subprocesses, training subprocess and the testing subprocess. The training subprocess is used for training a model. The trained model is then applied in the testing subprocess. The performance of the model is also measured during the testing phase. So to continue with this, in the training subprocess, we are using the naive-Bayes operator. And in the testing subprocess, we are using the apply model operator and performance operator. Now we are making the connections. In this naive-Bayes operator, we can see here, here the Laplace correction. And this is used to deal with zero probability values. So if we run this, we will get three things: the performance vector, at sample set, and the symbol distribution. In the performance vector, we can see here the accuracy as 95.33, and this is the iris dataset, and we can see there are two classes: iris setosa, iris versicolor, iris virginica. And in the design part, when we go to this cross validation, we can change the number of validation. If I am changing it to 5 and running, we can see the class precisions of each class is 100% for iris setosa, and it is 94% for iris versicolor, and it is 94.0% for iris virginica. So again, if I change the number of validations to 24, it will change. The iris setosa is now also 100%. Here it is 92.16%. It is 93.88%. So the class precision will be changing according to the number of validation. We can change it. So here we learned how this Bayesian classification or classifier is working for this iris data set.